We're going to solve systems of equations today, and we are going to have three variables we're solving for. So we're going to be solving for an ordered triple, which is an x-coordinate, a y-coordinate, and a z-coordinate. So my z, I put a little line through it so it doesn't look like a 2. So just as an FYI. So we're going to go ahead and use substitution in order to solve this ordered triple. And we're going to work through one example together and kind of see how that plays out. So the first thing we notice is that we have 3 equations now instead of 2, and each equation in our system has an x, a y, and a z. So we're going to use different layers of substitution in order to eliminate variables, and we'll be able to substitute values in order to solve. So let's go ahead and look at our 3 equations. We're going to first label them, and this kind of helps us to stay organized in our solving. So our first step that we're going to do is we're going to solve our first equation for y. So I'm just going to write down some notes so you can kind of keep track of what we're doing. So solve equation 1 for y. And what that will look like is, I'll just rewrite equation 1 here. Equation 1, solve for y. And now what I can do is substitute this equation in to equation 2, so I only have 2 variables. So instead of having x, a y, and a z, I will only have an x and a z. So we're going to plug in our equation into equation 2. So we're going to take equation 2 and substitute this in for y. So instead of writing y, I'm going to replace it with 2x minus 3z plus 20. And I'm going to go ahead and simplify. So now we'll subtract 40. Okay, so now I have an equation with an x and a z, and it's a lot more simplified than what I had to start with. And so now what I'm going to do is I'm going to plug my y. I'm also going to plug this y into equation 3. So what I've done, remember, is rewrite equation 1, and I'm plugging equation 1 into equation 2, and then I'm also plugging this into equation 3. So I'm essentially rewriting these last 2 equations to eliminate that y variable, and that will help me to solve. So now we're going to plug our y into equation 3. So equation 3 is 3x minus 2y plus 3z equals negative 9. Just like before, I'm going to go ahead and simplify. Combine like terms. Add 40 to both sides. So I have x minus x, or negative x, plus 9z equals 31. So now I have a new system where I only have 2 variables. Okay, so we'll say we have a new system with 2 variables. So x minus 5z equals negative 19, and negative x plus 9z equals 31. So what I can do now is call this equation 4 and this equation 5. And again, that just kind of helps me to talk about my equations and reference them. So now what I can do is I can solve equation 4 for x. So if I do that, I get x equals 5z minus 19. And then what I will do is plug that in to equation 5. Now I'm going to plug in equation 4 that I rewrote in terms of x into equation 5. So equation 5 is negative x. So I'll rewrite this for x. Plus 9z equals 31. Okay, so now I have a one variable equation that will be a little bit easier for me to solve now. I'll go ahead and simplify. Combine like terms. Subtract 19 from both sides. And then I get z equals 3. So what I have done is I have found my first variable. Woohoo, this is a cause for celebration. So I have one variable solved and I have two more. So remember, I need an x, I need a y, and a z. So if you remember, we have rewritten a lot of equations along the way, and we can use those in order to find our next variable. So if you look back, we have an equation that just has x and z. So I'm going to go ahead and use equation 4 to find my x coordinates. So when you're plugging it back in, it's helpful to use what you have and put it into an equation that only has two variables. So we want the variable that we have solved for, and we want one other variable. And again, the reason why that is because if we have a one variable equation, we can actually solve that. So now we're going to plug our z equals 3 into equation 4 to solve for x. So we have x equals 5 times z, which is equal to 3, minus 19. And x will equal, negative 4. Okay, so now I have the next one. I have x equals negative 4, and I have z equals 3. So now I have a lot of options because now I have two variables. So really it doesn't matter what equation I plug these values into, as long as they have an x, y, and z. So now I just need to plug it into something that has three variables. So I'm going to plug in z equals 3 and x equals negative 4 into equation 1 to solve for y. So again, it didn't matter if I used equation 1 or not. I just needed something with the x, y, and z in order to find that missing variable. So I'll just go ahead and rewrite equation 1 since I don't have it on the paper in front of me. So it's negative 2x plus y plus 3z equals 20. This is equation 1. And I'm going to substitute in what I have for x and z in order to solve for y. So negative 2 times x, which is negative 4, plus y plus 3 times z, which is 3, equals 20. So from here, I just simplify and solve for y. So negative 2 times negative 4 is 8, plus y plus 9 equals 20. So y will equal 3. So now that means my solution, so the solution to the system is x, which is -4, y, which is 3, and y is 3, and then z is also 3. So remember, you can check by substituting this back in, but you'll want to plug it into every equation. So just like when we solved the system before, you can plug in your x, y, and z into your equation in order to make sure it's a solution. And then to check your system, you want to make sure you plug it in to all three equations. Okay, so we're not going to go ahead and go over that now, but just as an FYI, because I know there's a lot of people out there that appreciate the ability to check their answer, especially when they have like an assessment, like a quiz or a test. They want to double check to make sure they're right. So this is always an option. You can always plug that back in order to make sure you actually found the solution to all three equations where they will meet.